So we will solve one more interesting question. Here the question states that we have a PCM system which uses a uniform quantizer followed by a 7-bit binary encoder. It means first we receive a message signal, we sample it with some say Nyquist rate, and then we each sample is represented by 7 bit of bits. So if the bit rate, so once we convert all the samples, we get a sequence of bits. So the problem says that the bit rate of this system is 60 Mbps, or okay, let's assume it's 50 Mbps. Then what is the maximum bandwidth of the message for which system operation is satisfactory? So the question asks that up to what maximum bandwidth, I mean one can choose a message signal of bandwidth W, or it can choose larger, but since we have already said that the bit rate of the system is 50 Mbps, so we have to find out what is the maximum bandwidth of the message for which we get this rate, or in other words, then operation will be satisfactory, right. So if this is your complete PCM system, this is your message signal, and we assume that the maximum or the bandwidth of this is FM. So we use sampling in order with you know the rate of sampling is Nyquist rate, we are using Nyquist rate. So RS is 2 FM. So if now this message, this is in time domain, and in frequency domain, let us say the signal is like this. So maximum frequency or the bandwidth of this message signal is FM. In time domain, I mean, it will be a signal like this. We sample it at different time instance. So the rate of sampling should be 2 FM in order to get the, in order to, I mean, no aliasing, right? You remember, I hope, that if we sample our signal twice the rate of the band, twice the bandwidth of your message signal, we do not get aliasing effect. So rate of the rate by which we are getting each sample is 2 FM, and now we provide each sample, or we represent each sample by 7 bits. So now the rate, the bit rate which we are getting at the output of the quantizer, and the, since you are now what you are doing, you have quantized this, and each level you have represented by 7 bits. So each sample, each of this sample will be represented by 7 bits. So the bit rate, this is the sample rate, right. So this is the sample rate. If you are quantizing this message signal like this, so this sample will be given some, will be assigned some value, and that each sample will be represented by 7 bits. So now the bit rate is 14 FM, and as our question says that we are allowing the system, the bit rate of the system is 50 Mbps. So if you pass a 50 Mbps of data from the system, I mean it's due to, there might be many reasons why we are allowing 50 Mbps. Maybe our channel can accommodate only that bandwidth which is suitable for this data rate signal of this data rate. So, the PCM system is giving you output of 50 Mbps, or the application demands 50 Mbps, you can say. So, so this 14 FM should be less than equal to 50 Mbps, right? Then only our system's performance would be satisfactory. So, FM should be 50 by 14, and if you evaluate, it will come out that our FM is maximum bandwidth of your message signal is 3.57 megahertz. So, if you encode your signal by 8 bits here, then what would happen? If you represent it by F1 M1, then the bandwidth, the bandwidth of the message signal which you can accommodate or which you can allow here would decrease. So, M1 will become less than F1. So, as you can see, there is trade-off, right? Because if you remember, I told you have to put a NT, you generally put a anti-aliasing filter here, which makes sure that the bandwidth of this signal is not more than a particular value which will be governed by this rate. Okay. So, if you and by doing this, of course, the accuracy of our network, our PCM system will improve if we represent each sample by 8 bit. Of course, it will improve, but we will lose in I mean, you have to, and you can do one if you want to fix your rate, but you want to improve your accuracy, then you have to put an anti-aliasing filter which have a cutoff bandwidth less than the previous one. So, there is always some trade-off, right? So, thank you.